Okay, this will be section 7.2, more on decimals. Okay, so let's do a review. So we have a theorem that basically says if we have a fraction in simplest terms or reduced to its fullest, if the denominator in prime factorization contains only 2's or 5's or powers of, then it terminates. I'm just going to do a couple of these. Let's do 4 over 34 because I can do that quickly. 4 is 2 squared, 34 is 2 times 17. That becomes 2 over 17. 17 is prime. This can't be reduced any further. Not just 2's or 5's. So this one, no. 14/35. So that's 2 times 7. 35 is 5 times 7. That reduces to 2/5. It's just 2's or 5's. This is a yes. And I'll let you work on the other ones. Okay, we can add decimals. Notice this isn't the best problem because there's no regrouping. You know, so that's not much fun because we can just put these together and not have to regroup anything. Here's another representation. You know, if we had the manipulatives, we could do that. Now I'm doing symbols. I'm taking each term, each place value, and I'm writing it as a fraction over powers of 10s because 2 is really 2 over 1. Now, I'm not so interested that you could do the math. I'm really interested in right here, what properties of addition were done here. I'll let you pause for a moment and think about that, because that's really the more interesting thing here. Well, look right here. Didn't we commute the order? Didn't we move this one over to here? So it's adding it in a different order. Plus, notice we've regrouped things in a different manner. We've changed the parentheses as to what we're grouping with. So the two properties here would be the commutative property of addition and the associative property of addition. Okay, so what makes this one a little bit different? Now let's do it and see why it's here. Okay, again, I'm going to commute and regroup. Do 3 plus 9. 5/10 plus 8/10. And I think I see why this is here, because I can see already that we have to regroup. we have 12, but this is now 13 tenths plus 15 100ths. So the 13 tenths, if I have some white space, that's 10 tenths plus 3 tenths. That becomes a 1 plus the 3 tenths. So now we have another 1. We have 12 plus 1. We have the 3 tenths. Do the same thing up here for the hundredths. 15 100ths. Is 10 100ths plus 5 100ths. Well, the 10 100ths, that's really 1/10, and then plus the 5 100ths. So down here we have one more tenth, and we have the 5 100ths to finish off. I'll finish in this white space below. So we have 13 plus 4 tenths plus 5 hundredths. It's 13.45. So this one we did commutative property, associative property of addition, and we had to review. That leads us to multiplying decimals. Okay, you were taught when you were multiplying that there's 2 decimal places here. There's 3 decimal places there. That means my answer has 5 decimal places. Well, there's your favorite word, why? How does this work? What's going on with this? So we have to learn how to explain that. So we got a rule, we want to know the reason why. Hey, I gave myself white space, good. Now I need my numbers. 2.53 times 3.214. Yeah, I shouldn't use that. It's really bad for multiplication. Use the dot. Did parentheses before. I guess the easiest way to explain this is I'm going to write this as a fraction. 2 plus 53 100ths. Then I'm going to multiply this. 3 plus 214 over 1,000. Well, I'm going to do the distributive property, but I'm not going to multiply everything out because I don't need that really. But I need 2 times 3 plus 2 times 214 over 1,000 plus 3 times 53 over 100. And now here's the big one. 53 over 100 times 214 over 1,000. The reason for the rule has nothing to do with that or that or that. It's all here. Because if we just do this multiplication, we get 53 times 214 over 100 times 1,000. I'm not going to do all the multiplication. I don't need to. This is 10 squared times 10 to the third. So remember what the rule was? It said 2 decimal places here, 3 here. You got 2 plus 3 is 5 decimal places. Well, when you multiply those, you add the exponents. You get 10 to the 5th. And that's where the rule is. It's because when we get down to the hundredths place times the thousandths place, we get the 100,000ths place, which is 10 to the 5th. That gives us the 2 plus 3 equals 5 decimal places. I'm not going to sit and discuss this, maybe during class, but just think of bad place value throughout this whole example. Remember, we emphasize place value in this class. This example is terrible. Just think of all the places you can see bad place value. Okay, I'm not so concerned with you doing this, certainly not by hand, because my gosh, we do have calculators for that. But I'll bet you know this one. I bet you're thinking, ooh, I moved that decimal place 3 places. Because that's what multiplying by 1,000 does. Okay, pretty much the last topic in this section is scientific notation. Something screwed up with their notation here. This is 5.872 times 10 raised to the 12th. Meaning, you're here, you would have to move your decimal point 3, 6, 9, 12 places over. That's a 10 to the 12th. Here, I'm moving it 1, 2, 3, 4 to the left. So that becomes 5.4875 times 10 to the negative 4th. So when you see something, I can clean up this 10 a little bit. If you see a 10 to a positive number, it's a big number. If you see it to the negative 4th, it's a small number. It's just an easier notation for these really big numbers. Now you see them in chemistry and astronomy all the time. Okay. Listen, really big number. So it's 4.13682. You always put the decimal point with only 1 digit to the left. I had to move my decimal place 8 times, so it's times 10 to the 8th. Same thing here. 2.31, but I moved my decimal place 345 times 10 to the minus 5th. Okay, 83.7, it's not a big number, but a lot of times we still want it in scientific notation. So it's 8.37 times 10 to the 1st. And if there's a negative sign, just make it here negative 1.0 times 10 to the 6/7. Okay, this is really times 10 to the negative 5th. So that means I'm moving my decimal to the left 5 places. So I'm going to need 1, 2, 3, 4 zeros, then my 6, 8, 4. So very small number. This is really times 10 to the 7th. I'm moving my decimal place to the right 7 places, which gives me 3, 1, 2, and 5 more zeros. 31 million. This is 10 to the 4th. This is just -4. I have 0, 8. I need 2 more places. -40,800. So I guess it gets interesting when we multiply. And this is why we actually do this, is to work with big numbers like this. So it's almost a distributive property, but not really, because I don't have 4 terms. I'm only going to have 2. I multiply the 3 times the 2. Now, that's going to give me 6. So it's almost worth just getting rid of that, actually. 3 times 2 is 6, times, now I do 10 to the 8th times 10 to the 5th. I add those exponents, I get 6 times 10 to the 13th. But what you really do is you put a 6.0 in there. And that has to do with the fact that we want our decimal place 1 to the right of the 6, so that 0 kind of demonstrates that. So a really big number. Let's do this next one. Let's do this one. 8 times 4 is 32. Now, 10 to the -5th, 10 to the 12th. I get 32 times 10 to the 7th, but we don't stop there because we only get one digit to the left of the decimal point. So we change this. We go 3.2 because I move my decimal to the left. That means I need 10 to the 8th. Because I changed that 32 into 3.2 times 10 to the 1st, and I end up adding that 10 to the 1st to the 7 to get 10 to the 8th. Okay, division. Apparently I have the same one here twice. Okay, division, you do the same thing, but now you would do 2 divided by 5. You know that's going to be 0.4. But I want to demonstrate it in here anyway. Times 10 to the -6 over 10 to the -8. So this is 2/5 is 0.4 times. Now we're going to subtract. -6 subtract -8. That's the rule of exponents. A to the m over a to the n is a to the m subtract n. That's why you took algebra all those years ago. So that's 0.4 times 10 to the +2. Now, I only get one decimal place. I need one. I actually have to move this decimal. I need that digit. This becomes 4.0 times, oh, that's old school, putting that X in there. Now, because I moved it to the right, I have to decrease that. That's just 10 to the 1st, or 10. So practice a bunch of those just to get used to the rules of exponents, moving the decimal place. If you end up moving your decimal to the left, you increase that. If you move it to the right, you decrease your exponent. Calculators do it. That's what that means. It really means 10 to the 4th. Or you may have one that just has an 04 up at the top, right-hand corner. Oh, dividing decimals. Forgot we're going to do this. Yeah, if we could do estimation, I wish we could get together and have a competition again. It gets fun when you add decimals. Okay, I don't like this either. because look at this. Place value, 4 times 30 is really 120. So this is 8, but where'd that 0.6 go and what magic happened? This was 6/10, suddenly now it's a 6. This is really strange stuff. I guess I'm not going to worry if you can do this. We got calculators. To me, the big thing would be something like this. Why do we get to do this? So I'm sure you learned like I did. You move that 2 spaces. You move this 2 spaces. So you've really created this because it's easier to work with these whole numbers. Like 32 in the 120 doesn't do 4, it only does 3 times. So I guess the reason I want to go, why can we do this? Well, you're really doing this. You're doing 1.2032 and you're dividing it by 0.32. Right here, I'm dividing by 100 over 100. Why do I get to do that? What property is in here that I snuck in here? Because now I'm claiming this becomes, well, I move this twice, 120.32 and move that twice, divided by 32, which makes an easier problem. So again, what property? I'll let you stew on that one. Because this is actually a really big concept in math that's going on here. Multiplying by something to make our life easier. So what did I multiply by and what property is that? And with that, I'm ending this. Why is it always so hard to get back to here? Bye.